Okay, now quickly, I'm going to just go over a couple of problems we did in the preceding class for the support course because it's very relevant. Okay, something that you're likely to encounter on the exam. And that's what we're doing now. We're trying to prepare for the exam. And also, we need to talk about systems 3 equations and 3 unknowns. Okay? That'll be due on Thursday. That'll be our last assignment. Okay, well, question, graph this function. Okay? Well, what do you do to graph function? First of all, what kind of graphs are going to be? Well, it's going to be a parabola because it's quadratic. Okay? To graph a quadratic, find the zeros, find the y-intercept, find the axis of symmetry, and find the vertex. It's easy to find the zeros. You plug into the quadratic formula. You know how to do that. I'm not going to go over that. Okay, right here it is. I will say the zeros are when y equals 0. That's what we mean. Okay, so y equals 0 if and only if x is one of the values given to you by the quadratic formula. So you're going to know y equals 0. You're going to get 2 values of x. Maybe you won't get any. Depends on the discriminant. In this case, you're going to get 2 values of x to give you 0, which is going to give you 2 points in your graph. Okay. Then you're going to find the y-intercept, which gives you another point in your graph. And if you think about what the quadratic formula is telling you, it also gives you the axis of symmetry, which I didn't label last time, but I've done a number of times. And then once you know your axis of symmetry, which comes right out of the quadratic formula, you plug the coordinate of the axis of symmetry into your function, and you get your y coordinate, which gives you the 2 coordinates of your vertex. That's something I expect everybody to be able to do. It's very likely you're going to see it on the exam. I don't guarantee it, but it's something you want to be prepared for because it's highly likely. Okay? There's some randomness in the way the exam's generated. Some people might get them, some people might not. I think you want to be ready to do it. Okay, so anyhow, we get the 2 values of x, which are very easy. Just plug in. We get -7 plus or minus the square root of 1 divided by 2. Okay? The thing I want to emphasize is, of course, then this is -7 over 2 plus or minus the square root of 1 over 2. Because division by 2 is the same as multiplication by 1/2. And multiplication by 1/2 distributes over addition or subtraction. Okay? Subtraction just being addition to negative. So we can write this then as -7/2, -7 over 2, and the square root of 1 over 2. Well, square root of 1 is just 1, so we just write that as 1 over 2. The reason that's important, well, first of all, if we add or subtract 1/2, we're going to get -3 or -4. That's easy. Okay. More importantly, the zeros, which occur at -3 and -4, from this form we see occur 1 unit right and 1 unit left of -7/2. Because if you got -7/2 here on the x-axis, -7/2 plus 1/2 is 1 unit that way from -7/2. 1 unit. Well, 7/2 minus 1/2 is 1 unit to the left of 7/2. So these 2 points, these 2 zeros, okay, x-intercepts, if you want, occur at equal distances on either side of what I say is your axis of symmetry. And of course, that's why this is the axis of symmetry. The only axis of symmetry you can have is one that's halfway between your zeros, because if it's anywhere else, you don't have symmetry. If it's closer to this one than this one, then it's not symmetric anymore. So you want to understand from your quadratic formula why the axis of symmetry is what it is. That's a question I could put on the exam. Now, it's a question that I'd put on for an extra point or 2. Not a question that I'd penalize you on. Penalize a question that I'd give you a little extra boost on. Because it'd be good if you understood that. Okay, well, then the rest is pretty simple. we plug in x equals 0 to get our y-intercept. And we got to know that x-intercepts occur when y is 0 and y-intercepts occur when x equals 0. And that tells you what to do to find your intercepts, okay? Something we said many times, make sure you have that firmly in your mind. So then we put our 0, our x-intercepts here. I say zeros at x equals -3 and -4. Plug in 0. Y-intercept occurs when x equals 0, so you plug in 0 for x, and you get 12. Okay, 0 squared, 0, 7 times 0, 0, and 12. That gives you -1/4. I worked it out down here. Okay, so now we have the coordinates of our vertex, so we can completely characterize this quadratic function. Okay, let's graph. Also, we can see that this is just your basic quadratic function, shifted left 7/2 unit and down 1/4 unit. The vertex goes from 0, 0, which is where it is on your basic squared function. And you shift it to the left and you shift it down. You don't have a vertical stretch on this one because you don't have a number in front of x squared. If you have a number in front of x squared, then you have to vertically stretch the thing before you shift it. Okay? And that tells you what the formula ought to be, because you understand how vertical shifts and vertical stretches affect the equation of a function or the formula for the function. You understand that shifting 7/2 unit in the negative x direction, you replace x by x plus 7/2. And then you add whatever your y shift is, which would be -1/4. And you want to understand transformations at that level. Okay? Because that will be on the exam. You will have to do transformations to show how well you do or don't understand them. Okay? So be prepared for that. You know, we did some of this last time, but we want to make sure that we're in shape to do this for next time, because next time's our last class. We want to make sure we understand how to do 3 equations, 3 variables by elimination. So what we do, we've got 3 equations, 3 unknowns, like 2x plus 5y minus 3z equals 7, so many x plus 7, 3 of them, right? Okay. So the process is eliminate a variable from 2 of the equations. You can pick on any variable you want to, x, y, or z, okay? And then eliminate the same variable from a different pair. Okay? If you eliminate from the same pair, you're just going to get the same thing. Then solve the resulting system of 2 equations. And then either plug your solutions into one of the original equations and solve it for the remaining variable. Okay? Make sense? Now I'm going to give you a fairly simple system that hopefully we can work through in not too much time. Okay, there's three equations. You can already see, make a decision about what variable you want to pick on. X is not the easiest variable to choose, but it's not that hard. So if you want to choose X, that's okay. You might want to look at the other variables and see what's easy. I actually think Z would be the easiest, but if you're comfortable starting with X, you can do it. Okay, now let me put some numbers on the right-hand side. Let me think so it comes out nicely. Okay. Oh man, I can't keep the numbers in my head. Try again. Okay. That'll be 20. That'll be 9. And that's going to be 9. That's interesting. I'll double check those numbers. Go ahead. See what you get. Sure. Not 100% sure. It might not work out as pretty as I hope, but that's what we're going to use. Okay. Okay. I thought I had my numbers right, but I don't think I did. I know what the solution was supposed to be, and it's not. So, one way or another, we can do this. Now, give myself enough room. Okay, so let's try them out again. Equation 1, 3x minus 2y plus 7z equals, equation 2 is 2x plus 4y minus 2 equals 9. Equation 3 is 4x plus y plus 2 equals 9. Now I'm going to take the easy way out, okay? And I'm going to do something a little different than what Lowry did. Most of you did pick on Z because you got one in front of all your, of 2 of your Z's here, and just a 7 here. Z is going to be easy to eliminate. I'm going to do that, and I'm using a notation that tells me at every step what I'm doing, okay? So try to do these in a form that you see me doing it, okay? You'll be clear and you're going to communicate it better. Now, if you've got a better form, that's okay, but you want to document what you do at every step. So first thing I'm going to do is I'm going to do equation 2 and equation 3. I'll write those out over here. I got equation 2 plus equation 3, because that's going to eliminate Z. Well, if I add up my x's, 2x and 4x gives me 6x, 4y and y gives me 5y, and 9 and 9 is 18. So right there, I've got an equation. Now I'm going to write it up over here. Equation 2 plus equation 3 gives me 6x plus 5y equals 18. Okay, well then I've got to eliminate Z from another equation. Now I'm going to do it this way. I'm going to take equation 1, which is 3x minus 2y plus 7z equals 20. And then I'm going to add 7 times the second equation. That'll give me a negative 7z. Now, 7 times 2 is 14, so I get 14x. And I get 28y minus 7z equals 63. Assuming I've done my arithmetic correctly. And some of you are having some trouble with your arithmetic, so be very careful. Use a calculator to do your multiplication and stuff, and do so, especially if the numbers get big. Double check the multiplication, because otherwise, very typical that somebody will multiply one of the numbers by 7 and forget to multiply the other numbers by 7. Is that okay? Avoid that mistake. Okay, well, anyhow, we get 17x 26y equals 83. Just didn't consistent with the numbers I thought I was using, but that's okay. Okay, so 7. Well, this is equation 1 plus 7 times equation 2. 17x plus 26y equals 83. So at this stage, it gets a little ugly because numbers are getting bigger. I'm going to actually have to either multiply this one by negative 17 and this one by 6, which is probably going to be the easiest, or maybe multiply this one by negative 26, this one by 5. Okay. Either way, I'm going to get some numbers up into the hundreds. So obviously, I want to have some kind of a calculator, the one you're allowed to use in the testing center, for example. We'll do those numbers for you just fine. Okay. Before I do that, I want to get an idea what this system looks like. I'm going to grab. And often, I will ask you to graph systems of 2 equations of 2 variables. It's a good idea to do that if you're doing 3 equations and 3 variables. Be very careful that these 2 equations work. So then you can get a picture of what the solution ought to be. So if you make a mistake with the ugly numbers you have here, you'll be able to trace it down quickly. So the x-intercept occurs when y equals 0. I'm not going to write all that out. I've done it a number of times. I wouldn't mind doing it again, but for time, I'm just going to refer you back to what we've done a number of times. Okay. So if x equals 0, y is 18/5. 18/5 is about 3 3/5. But here is 0 18/5. And if y is 0, x is 3. Oh, excuse me. So it gives you 3 0. And there's my line for 6x plus 5y equals 18. And I have a feeling I'm off the edge of the board. See how far this goes. Okay. Then here, again, my x-intercept is going to occur when y equals 0. That's going to be 83/17. Well, 17 times 4 is 85. So that's going to be out here at approximately 83/17 0. And if x equals 0, that's going to be a pain. Y is 83/26, which is a little over 3. So it's going to look like this. Well, we're at least lucky enough that these two intersect somewhere in the first quadrant, okay? So what are the coordinates at this point? Well, you'd want to go into a little more detail about marking off your axes and stuff. I'd start by seeing that all these numbers are less than 4. So you start with, maybe put 4 here. So 2 would be here, 3 would be here, and so forth. Okay. This is not going to be necessarily a great estimate, but this looks like it ought to be something about 2.7. Let's just say 2.7, 1.7. I didn't go to a lot of trouble with that estimate, but I know now if I get something like 387, 512, then it's not right. Okay. So don't expect my estimate to be that close because these lines are very close to parallel. And when the lines are close to parallel, it's hard to tell exactly where you're, or very precisely where your intersection is. Okay, well, I'm going to continue now. So I'm going to take the first equation times -17. The second equation times 6, which would give me -112 x minus 85y, and 17 times 18 is 289, so -360. I actually saw that in somebody's paper. So somebody's mind is working a little like mine, so you want to be careful. You don't want your mind to work like mine. Okay, so then we get 112x. And 26 times 6 is 156. And that gives me 498. I think. Is that agree? Okay. 6 times 20 is 120. 6 times 6 is 36, 120, and 36 is 156. But obviously I did something wrong, which is no surprise. I started to write 102. I didn't really care because these cancel out. Let's do it right. 102, not 112. Okay. Either way, we end up with these. Maybe I did these right. And this ought to give you like 71y. Because 80 and 70. It's 15, 6, and 6. That's good. And this gives me that out of these. This is 192. So the y is 192 over 71. Now all I've got to do is plug that fraction into one of these equations and solve the really ugly fraction that comes out of it. Okay. Now, what's 192 over 71 though? That's like over 2, but it's not quite 3. So, 2 would be, let's say 18/5 is here, and 4 would be here, 2 would be about here. So that's a little more than 2, but not quite 3. So the actual intersection point would be a little higher here. But it's not a terrible, since these point lines are so close to parallel, and since I didn't line everything off with a great deal of care, it's still in the reasonable ballpark, okay? Now, if y equals this, then x is probably going to be a little bit less. So I'm going to have to guess that x will be between 1 and 2 parallel. So we plug this into either equation. And numbers are smaller in this equation. I'll do that. Which will give me equation 6x plus 5 times 192 over 17, 71. Equals 18. Multiply everything by 71. That's really not too hard. That's 426x. 5 times 192 is 1,000 minus 40. So it's 960. And 71 times 20 would be 1,420. And subtract 271s. I don't want to do that. 142, 1420, minus 142, 13, 1278. Maybe. You got your calculators. Okay. So that 426x would equal this minus this. And this minus this is like 228. So x would be 228 over 426. Okay. 4 will go into 228, but 4 won't go into 426. So, that reduces a little bit, but maybe not that much, because that gives me 557, 3 times 17. Yeah, you get some cancellation there. Okay. I think 12 goes into this, and 12 goes into this. Anyhow. Now, I'm going to be fairly careful so that you don't end up with terrible fractions, but it can still happen, okay? If you end up with a terrible fraction, deal with it, okay? But if you have to round off and the fractions are really terrible, I might not penalize you too much. If you've done this fraction and decide you better just round this one off, I'll be okay with it, right? So anyhow, this gives you something like 0.6. Okay, so it doesn't agree great with the graph, it's fairly close. Now, if you plug these two numbers into one of these equations, you'll be able to solve for one. Okay. And I'm not going to go through the details of math because there's plenty of exercises where the numbers are more reasonable. This illustrates the process. And the main thing I want you to take from this is the idea of writing this out really coherently. So it's clear to anybody that looks at it a little bit what you did and when you did it. So if you just write this and this without, or I'd say this and this, because this and this are pretty obvious. We just take it directly from the equations. But this and this aren't as obvious. Okay. You don't say what you did, it might not be clear. And over here, if you don't say what you did, well, two equations of two unknowns, it's a little more clear. So you want to say it. You want to write it on your paper to reinforce what you're doing, even though you understand perfectly well. So to stick with it longer. Okay. Okay. Okay, looking at this review sheet, which this isn't comprehensive over the whole course, but these are basic things that you really need to know how to do, okay? So, number one, we want to factor this thing. Well, lots of luck, that one won't factor over the integers, and I don't think we're going to factor it over the rational numbers either. But we could try. You could say, okay, we'll try x minus 18 times x plus 1. Or x plus 18 times x minus 1. Out very clearly. Well, this is going to give us x squared minus 17x minus 18, right? We're going to get the minus 18. We're going to get a negative 17x. This is close. Okay, but not quite. Okay, so not quite doesn't work. This clearly won't work. This is x squared plus 17x minus 18. Not even close, because that 17 is not negative, right? Well, it's clear that our negative number has to be greater than our positive number when we factor negative 18. Okay, now we could try x minus 6 times x plus 3. That's x squared minus 3x minus 18. That's not worth much. And it's very clear if we use numbers less than 18 when we factor, we're not going to get even close to having a negative 18 there. Okay. I'm not going to put down etc. To show that this doesn't factor, you want every pair of possible factors, okay? Like 6 and 3, 2 and 9, right? Okay. And you'd want the negative to be the bigger of the two numbers. You have to have a negative and positive to get to negative 18. So it wouldn't take long to list all those possibilities and say none of them work, so it doesn't factor, okay? So if I say to factor something that doesn't factor, show me why it doesn't factor. Please show me enough that I can tell that you can determine for sure. If it's a number that has a whole lot of factors and you have to write out a page full of trials, well, don't bother with that. Show me the pattern that you would use and just say, well, this pattern continues, it just doesn't work. Okay, show me you know what to do in order to factor. Okay. Now, the second one, I think, does factor. Okay, well, you can factor 2 out of this, first of all. So if you can factor monomial, you do factor the monomial. Okay. And then you can go with trial and error. But you can see 14, well, you're going to have 14 and 1, right? Those are factors of 14. And you're going to have 7 and 2, and that's all there is. And pretty quickly, you see 7 and 2 works. So this would be 2. Okay. And if you see it, write it down. If you don't see it, show me your trials until you run out of trials or until it's obvious that they're not going to work. Okay. Okay, 3 and 4, I'm going to refer you to the MDE 61. Okay. And I think a lot of these were also addressed in the MDE 60. I'm using the same sheet for everybody. It's a little stretch for the MDE 60. That's intermediate algebra. It's all intermediate algebra, so it's okay. Excuse me. Okay, now we want to look at number 5. And what you have is a fraction that's written like this. 1 slash quantity 1 slash quantity x plus 6. What's this mean? This means 1 divided by 1 over x plus 6. Or we could say 1 over 1 over x plus 6. Okay, well, this means one divided by 1 over x plus 6. Which is 1 over 1 times the reciprocal, 1 times x plus 6 over 1. We put that as a 1 over 1. That equals 1 times x plus 6 over 1, which equals x plus 6 over 1, which equals x plus 6. Now that's all the steps that could conceivably be written. But it just comes down to understanding that a slash means division. And you can write a division as a fraction. Okay? So ponder that. What more explanation on the asking? Okay? Give you more examples. Okay. Number 10. Actually, I got to refer you to the MDE 61 for that one because we did that. Okay. We did that one in some detail. One you do want to understand. I'll write about briefly. And I'm just going to write down a couple of results. F of 6 on this one would be -4/3. F of 5 would be -6/5, I think. Okay, so that's -20. That's 18 -38 over 15. I'll put a question mark there because I've got these in my head. And that doesn't seem as familiar as it ought. Okay. Now the whole point of this thing is though, you use function notation, you plug it in. Okay. And of course the function is f of x equals 4 over x minus 2. So to get f of 6, x would be 6, so you have 4 over 6 minus 2. Well, if you do the fraction, 4 over 6 minus 2 is -4. Yeah, because it's 2/3 minus 2. Okay. And f of 5 would be 4 over 5 minus 2, which would be -6/5. So if I do f of 6 plus f of 5, we get this. But f of 6, and it was f of 6 and f of -5. I put 5 down here, but I'm going to leave it. And you can look back at what I did in the 61 if you want to see different size. -5. It's going to work out the same way. F of 6 plus 5 is f of 11. And that's 4 over 11 minus 2, which equals 4 over 11 minus 22 over 11, -18 over 11. And this and this are not equal. And the lesson of this, and I emphasized in the 61, I'll emphasize it to lessons here, is that f of x notation doesn't act like multiplication. If f was a number multiplied by 6 plus 5, then it'd be f times 6 plus f times 5, right? But this isn't multiplication. This has nothing to do with multiplication, okay? Function notation is not multiplication, so don't treat it as if it was. Okay, and this is just an example to show that it doesn't work. If the function happens to be linear, it would happen to work. Otherwise, it'd be very unlikely for it to work, except maybe for 1 or 2 numbers. Okay, so this is number 10. And again, I did more detail in the MD 61 if you want to see the detail. The bottom line is the two aren't equal. Okay. Okay, 13. completing the square. I'm gonna defer that one. It's something we didn't emphasize a whole lot in this section. Then 15. Goes back to our friendly it's actually an equation. We want to solve that by factor. Well, this factors as this, okay? Well, if you got two things that multiply to give you zero, one of them better be zero. Could be either. And x plus 3 equals 0 means that x is negative 3. Or x equals negative 4. Okay. Quadratic formula, which we already saw earlier, but plug the numbers into the quadratic formula. Give us our negative 7/2 plus or minus 1/2. Now you could keep everything in the numerator. Negative 7 plus 1, negative 7 minus 1 divided by 2. Either way you want to write it out. Then we get negative 3 or negative 4, which agrees with the solution we got. A factor. Now in a free calculus course where everybody really has the prerequisites, and we don't have to make some adaptations, and we didn't have COVID, so nobody had really great prerequisites, or very few people would, okay? I would do this by completing the square and show you where the quadratic formula comes from. But you can only push so hard. Okay, it's unfortunate. But you can probably live just knowing that. Okay. If you ever need completing the square, you can do it. Okay. Well, we've got 3 minutes left. What can I do in 3 minutes? I could dance for you, but that would ruin your whole life. Okay. Let's see. Got those, got that. There really isn't time to look at number 17, although that's high on the list, so we can at least start to look at it. Okay. This is kind of interesting. It's an important application. I think you've seen it in your open math. There's your profit. Okay. And X is the cost, the price you charge for a widget. So What value of x makes p of x 0? Well, solve the equation, p of x equals 0. Of course, p of x is this, so you get 7,000 minus 0.8x times x minus 16 equals 0. Okay. Now multiply this through by x. You get 7,000 x minus 0.8 x squared minus 16 equals 0. Now I'll give you a chance for glory here. As soon as I say Paul. Okay. So very good. I asked, and somebody identified this as a quadratic equation. Because you can put it in the form negative 0.8 x squared plus 7,000x minus 16 equals 0. Okay. And now you can solve it easily. X equals negative 7,000 plus or minus the square root of 7,000 squared minus 4 times negative 0.8 times negative 16. All that over 2 times 0.8. Okay. Now, I'm not going to finish it. This number here is pretty small, so this is pretty close to 7,000 squared, right? Which means when you take the square root, it's going to be pretty close to 7,000. Which means some things about the model mean maybe it isn't a very good model, or maybe it really is. So you would complete this, but the problem only asks you what value of x result in profit 0, and what p of x is maximized when x is halfway between these two values, right? Now, what's halfway between the plus value and the minus value? Halfway between is negative 7,000 over 1.6. Now, I will say this doesn't make a lot of sense in terms of what it says the model is about. I don't see where I made a mistake. That might be a good matter. Oh, wait a minute. This is negative 0.8, so it's going to be positive 7,000 over 1.6. Now that's approximately equal to say 4,300 or something like that. So halfway between the two values is 4,300, which means that you got to charge 4,300 bucks for a widget to maximize your profit. Okay. So that's, I'd like to give you a more detailed explanation of that, and I might do that next time if you ask. But we're over time, so we've got to stop. This should have been number 9, not number 10. I intended to do number 10. So be sure to ask next time and we'll work it out. But try to work that one out. We substitute just the symbols instead of actual numbers. Okay. So that's one I definitely want to look at. I'll make myself a note and hopefully I'll see it. Okay.